Hightech at SiPearl BW. Technologietransfer leicht gemacht.
Welcome to our podcast, HPC powered by Accelerate. My name is Andreas Wiese. I'm from SiPearl BW, one of the partners at Accelerate. And we have another partner of Accelerate with us, Craig Prunty. He's Vice President Marketing and Business Development at SiPearl. Glad to have you here.
Thank you for inviting me. Yeah.
Craig, could you please briefly explain the objectives of the European Processor Initiative and how SiPearl fits in there? What's your role there?
Sure. So the EPI was created by the Euro HPC JU joint undertaking, and it was created not long after the Euro HPC JU was created. So if I even step back a second, the focus of the Euro HPC JU is to grow HPC in Europe, focus on this at the system level and at the component level. So the EPI, the European Processor Initiative, is looking at the component level to develop CPUs and accelerators for HPC. Now they can have other uses as well, but the target is to look at them for HPC. The second, if I can jump a little bit, so the second question is what is HPC? Classically, HPC is scientific workloads. This is now growing, let's say, beyond that with the birth of AI and the merging of AI in terms of what a classical data center is and what a classical HPC is. So the EPI has looked at all of this in general. Mostly we're focusing on classical scientific workloads, the classical HPC, but we are looking a bit beyond that as well.
And how does it fit into the Accelerate environment?
So in the same sense, Accelerate is looking at how can we develop workloads, and one of the goals of Accelerate is to look at how can we port workloads onto, for instance, the SiPearl or the EPI CPU processor. So we're also in Accelerate, they're working with BSC to look at some of the acceleration capabilities and how can we port onto that. So it's really looking at, as a center of excellence, how can we port workloads onto European technology, or at least that's SiPearl's focus in terms of Accelerate.
And why is the development of low-power European processors crucial for this extreme scale computing and high-performance applications?
I would say let's go beyond just extreme scale computing, but in general, if we look at Europe, uses about 20% of the world's HPC, or they build about 20% of the world's HPC. But the underlying technologies, very little of this is actually European. So we're taking European tax dollars and we're shipping it overseas. So one of the goals is to create technology in Europe, keep it in Europe, and build ecosystems around this, so European jobs. But if we look at, for instance, developing CPUs, okay, but CPUs need advanced packaging technologies. So it's a way of creating ecosystems of work done in Europe. Now, there are also sovereignty reasons why this makes sense. There can be embargoes or other things. We've seen that in the recent past. So European technology, let's say the capability to have technology in Europe that's European, then can help you to avoid any embargoes that come. So the sovereignty issue also matters. But ultimately, the goal is to create a differentiated solution. And in SiPearl, we're focusing on some specific markets, and we do specific designs in our processors, as any small company would against large companies. So you're looking, how can I specialize, and then find a niche market, and then develop that niche market.
Okay.
I don't know if I answered your question or not.
Yeah. Well, you did. Some people say that extreme scale computing is a niche market in itself already,
yes.
But
yes.
What other markets, can you put, business areas on that? Or?
Well, so does extreme scale, for me, extreme scale looks like exascale, and growing beyond what's after exascale. But the technologies used there also have a place in, let's say, HPC down to the workgroup level. Now, every system is slightly different, but you could say extreme scale is looking at pushing the boundaries, and then it benefits all levels of HPC, right, and even data center. From our point of view, an HPC processor is a data center processor with certain specializations. Yeah. So ultimately, we build data center processors focused on HPC.
So in fact, in the mid and the long term, we are not really just talking about niches, but the idea is really to have this kind of trickle down later also to the desktop and beyond even.
So desktop in terms of a server, yes. I mean, we're focused on server, not on laptops, let's say, right? But yes, absolutely. So this technology, the technology we're using, so certainly ARM processors, you're seeing those spread across the market. There's a number of people building them. We're focusing, we have, I'm answering questions that you're probably going to ask later, but we have HBM in package. So we're looking at what we consider to be modern HPC processors. 10 years ago, HPC was targeted at CPUs. And if you wanted a high impact score, you had a CPU to do this. And CPUs have, over the last 20 years increased their vector processing capability. But today, accelerators are a real part of any HPC system, certainly at exascale, right? At high levels of HPC. That doesn't mean there aren't systems that don't have accelerators. There will be. But anybody who wants a high score in the top 500 uses accelerators because it's the most efficient way to get a high impact score. That's what acceleration does, right? It's efficiency by targeting certain kinds of applications.
Although I would say LinPack is not everything. And,
I 100% agree with you.
Okay,
it's
just
a
to
measure.
make that clear.
This is exactly what we're saying as SiPearl. So we should not focus our CPU design on LinPack. That doesn't make any sense in a modern system. We should be focused on real workloads that people care about. If you want a high LinPack score, get some GPUs, put them in, get your LinPack score. These can also be working for AI training and other applications. The CPU should be managing all the workloads that are data bound. They should be all the workloads that don't port well to accelerators. We can say GPUs because GPU is the main accelerator used today in HPC. And then they should be orchestrating the accelerators. That should be the function of a modern
a good combination.
Exactly.
And what impact do you anticipate onto the European computing landscape? So let's say if 5 years from now, there will be much more than, or much less than the 20% coming from abroad.
Right.
Is it just a replacement that we don't need to go shopping somewhere else, or is there more?
Well, so in any company, we're looking at future technologies and how do we integrate these into our processor families. And we're looking at, what IP do we bring? And again, what markets do we serve well? So we are looking at HPC with our initial offerings. Beyond this is data center. Now, any processor today, AI is important. So how do we support AI? For CPUs, generally speaking, this is inference, not training. For accelerators, typically they're more targeted at training. So AI acceleration, and that's in two different ways. One is AI inference, so AI as the workload, and the second is AI to improve existing solutions. So AI is very good at optimization. So can we look at things like data movement in the system and apply AI to where data sits? Right? So things like this are also interesting problems to look at.
But to be a little bit more specific, so why will it be better to work then in 5 years with SiPearl than, let's say, with NVIDIA or AMD? Well, they will still be there. So, and if it's just the same CPU, is that...
So it's not the same CPU.
Okay.
Again, so what you're seeing today, let's go back 10, 15 years ago. At a certain point, Intel didn't have competition. AMD was there, then they were not there.
I remember.
Right.
Well, prices were very high then.
Prices are high and the innovation is less. So I'm speaking generically. I'm not going to talk specifically about SiPearl's roadmap and features because that's under NDA, right? So speaking generically, you're seeing Moore's law slowing. I won't say it's ending. It's slowing very much in terms of the transport, and the compute part is still scaling, but it's scaling. It's more expensive to scale with less returns, generation over generation. So this is leading to an explosion of development in other ways, packaging technologies, chiplet solutions. So you're seeing disaggregation at the system level, and you're seeing more and more aggregation at the package level. So the component is moving toward becoming like a motherboard in terms of what functionality you can put in there. We're quite a ways away from a chiplet marketplace, but we can see that coming on the horizon. So we're seeing more and more specialization in terms of CPUs. You're seeing more competition, and this is creating innovation or serving innovation, perhaps not creating it. SiPearl is the same. So we're looking at where do we go in terms of our 5-year, our 7-year roadmap. What innovations are we going to bring? How does this serve the markets? What's available as innovations to us? Now, why does having a European processor make a difference? Again, this comes back to ecosystems in Europe and development in Europe. Already, if we look at the EPI, this is a consortium of a number of actors, whether it's universities, industrial, academic. So it's creating an ecosystem already that's looking at what does it mean to have a component that we want. What features would I put into this, whether it's at a CPU or an accelerator level. SiPearl then spun out of the EPI, and we can talk about that in a minute about but we spun out of the EPI. We have to go and find our own funding. That's another ecosystem to create in Europe. We're not good at funding tech startups. We can either do software companies that require very little, or we can look at funding large companies that exist and sort of providing loans to them. We know how to do these things, but let's say high-tech startups that require a significant amount of money to fund, we're starting to get better at this, but we're still way behind Europe the USA and China on this, right? So that's an ecosystem to create. And we talk to a number of small companies that want to know how we're doing, what do we do for funding, so they can follow in this. And hopefully this opens an ecosystem of...
Right. So things like co-design, etc., will be much easier with a European company than another one.
So co-design is another element in terms of the EPI itself. I was talking more about on the funding side and getting sort of a private funding for companies. And there's a certain risk profile to this that Europe isn't used to. We talked to some of the European institutions, for instance, and they're... In the US, companies get funded with the expectation that you have 1 or 2 that do very well, another 2 or 3 that do okay, and 5 that fail. But overall, this is going to net you a good return. Europe more has the idea everything I fund should succeed. That means you're not taking any risk on these companies. You're only finding companies that have already succeeded.
Venture capital without risk,
exactly.
Doesn't work.
Your return on investment is usually not very good in that case. So it's not really venture capital in that sense.
So you're even starting, let's say, or want to start a mind change there, and for the benefit of much more than just the processor industry.
That's also an ecosystem. The idea of funding companies, and there are people here that understand that, certainly. But getting the wider investment community in Europe to think that way is important.
I definitely agree. You talked already a little bit about the technical aspects also of the API processors, but could you say a little bit more? Where is it in power efficiency and performance and scalability? Where is it different or better than what we have now, as far as you can?
Sure, we're focusing on a few things in terms of the differentiation of our processor. So one is sovereignty, and there's some value there, but we've covered that already, so I won't talk about that. So specifically in terms of technical, we're making choices in terms of putting HBM in package, which is we're not the only company to do that. We're not the first company to do that, but it's looking at then how do we work well for codes that are memory bound. And again, in modern systems, we see that you have strong compute and acceleration, and you're seeing more and more kinds of acceleration being brought in. So we think then that the workloads that aren't necessarily compute bound but are memory bound are important to serve. One, that has a cost in terms of packaging, in terms of power consumption of the chip itself, because HBM is more expensive in terms of power consumption and cost per byte than, say, DDR. But it gives you a big return in terms of memory bandwidth. We look at the vector processing, the size of our vector processing. And again, if you look at a Pareto of what workload, the range of workloads you see being used, somewhere between, let's say, 200 bytes and let's say 256 and 512 is the sweet spot. Maybe 300, not bytes, bits, 300 bits would be a sweet spot. But now more of the compute-bound workloads are getting offloaded to GPUs. So this is even shifting that center of gravity of where the sweet spot for workloads is. So we've decided to use 256-bit vectors in our RIA 1 processor. And again, the focus here is to serve real workloads and the most energy efficient. Now, building a bigger vector processor, the processing engine, is costly in terms of area and power. And you can potentially try and power this down, but even when you're running 256-bit vectors, usually it's running that whole 512-bit engine, right? So again, this is a choice for power consumption and area in the chip, and where do you focus in terms of the capability of your chip? So the third thing we're doing is we're using ARM cores. ARM is not magic. They have very good cores. We've seen this at AWS with the Graviton 3. Other examples of, we're seeing Grace now come out. It has very good performance on the Neoverse cores. We're seeing good power consumption in all these systems. Why? Well, the cores themselves use less energy, not because it's magical and ARM defies the laws of physics. It's because it's a new ISA. And with a new ISA, you don't have all the backward compatibility constraints you have. x86 has been around for quite a while. It's had a number of generations. Each generation adds something, and you have to support the backward compatibility. So this creates a certain amount of bloat in the cores themselves, just naturally. Any new ISA would have this advantage, let's say, in terms of power consumption. But the second thing you need from an ISA is the software ecosystem. Again, these are server processors. And a server processor, it's not like we bring our software and just give it to HLRS, for instance, say, run this. You're taking software from a number of different sources. So if it's open, much of it's open source, some of it's private company. And this takes time to develop. ARM has been working on this since, we could argue, 2008 with the formation of Calzada. We could argue in Europe since 2010 with Mont Blanc. There's been a number of, worldwide, there's a lot of work being done at, in the DOE labs, in Riken, in Japan. So there's been a huge push in the industry to make this software ecosystem for ARM viable. And that takes time. So there's 3 ISAs today that potentially you can use for server. 3, let's say, living, right? So there's PowerPC.
Still.
It's kind of, it's let's say, less and less focused there. There's x86, and that's 2 companies today. And the third is ARM. There are other ISAs coming that would like to work in this, RISC-V, but the ecosystem for CPUs isn't fleshed out today at all, and that will take time.
How closely is this related to the compiler issue? What roles do the compilers play as between the application and the CPU? So
let's say there's a whole software stack around this, and the compiler is in many ways sort of the base layer we have to work on the hardware layer. Every company does, but we do that ourselves, right? But if I look at what's sort of open source and available, so you guys start with the OS. So if I look at HPC, I have SUSE, I have Red Hat, some Ubuntu, very, very little, but some. Ubuntu is more used in the data center today. But these have to be ported, and you have to be upstreaming regularly for this. So, for instance, if I was to have a RISC-V CPU, I need to make sure that I have first I roll my own Linux, and then I start porting any changes or required elements upstream, and then they have to be accepted by Red Hat, SUSE, the Ubuntu community. That's, I would say, the base layer. Then I have all the middleware stacks. That has to be ported. Then I have libraries that have to be supported. And
they have to be optimized.
Exactly.
So make use of the features of the CPU.
Exactly. The OS is a part of it, but the OS itself could probably be ported in a couple of years across the HPC stacks, let's say. And even for data center, probably faster. If Ubuntu is pretty commonly used, and that port goes pretty quickly. The optimization piece is a different element, but that went. I remember in 2014, 2015, working with, maybe it was in 2013, working on ARM CPUs prior to SiPearl, with Red Hat, getting ports done, and it took some amount of time. We had to get into their process, but that got done relatively early. Then it's getting all the middleware stacks, and then the last piece is getting the ISVs to port, and that's something that's still happening for ARM today. So it's a process throughout the entire stack. But the OS is an important element. I would say it's the base layer in a way.
And it brings us back then again to the whole ecosystem that's going to evolve around
Exactly.
that. Let's take a look a little bit more towards applications and future utilizations. Beside these extreme scale computing and HPC, big data applications, what do you think will be other emerging applications you could see where the API processor would fit well?
Well, so we're looking at a number of different verticals, and the COEs are in Europe are part of this. HLRS and Accelerate is one of the COEs we're working in actively. But there's a number of different verticals at HPC, and we see them all as potential applications for RIA for two reasons. Either they're porting to GPUs and will orchestrate GPUs, or they're looking at their memory-bound codes. Where can they get advantage there? If you want to look at specific verticals, so manufacturing with CFD, EDA, and we'd love to run ARM on ARM today. And ARM is running their EDA on ARM processors today. So, that's definitely interesting for us. Typically, in terms of how we're looking at the market in Europe, is we're working with some of the big research labs, and they're working with different industry. But, if we look at weather and climate, is certainly interesting. We have interest there. Energy in general, and that can be either the classic oil and gas or new energy sources. We're having discussions with these people. So I don't see, I would sort of turn around, I don't see any of the classic verticals where we can't play. But again, it very much depends on the system design and what the customer wants. Right? And their specific code.
So very likely to start at the most promising ones, and then others might follow.
Where we see it actually starting is in the, if we look at how Europe is structured, it's a little bit different than the US in the way that the big labs are structured. We have national labs. Germany has 3, but most companies have one central national lab. And then the industrials in that company, the more important industrials, often work with those labs. And then all the scientists in that country also run on this system. So it's a broad range of applications and also some industrial development. So we're working with these central national labs, and then that gives us a sort of a radius around each of these with the different industrials that are working with these labs.
Okay. So you've mentioned the COEs, and you are a partner in the Accelerate. I don't know, phase 1. Have you been in there? No, but you're definitely in phase 2.
Starting in phase 2.
You were starting in phase 2. How does this? This also, well, on one side, processor development sounds like a thing you go somewhere, you develop a processor, and then there it is, and everything's fine. But you already showed it's not like that. There's an ecosystem around, and you have collaborations a lot. How does the COE, the Accelerate project, fit in there?
So again, the function of the COEs is, in essence, a co-design. In that we're looking at how do we port end user codes onto technologies, at least from the development that SiPearl is doing in the Accelerate and the COEs. So for us, it's a big value, because when we go and talk to end customers, and even when we respond to RFPs, part of this is based on running on codes. So if the COE is there to look at how do we port, which is usually, honestly, pretty easy, the porting part, and then how do we, optimize. Thank you. So then how do we optimize? That's the part that really is important in the COE.
That's the crucial part, I guess, if you don't get optimization right.
But that then, from our perspective, this is also working with end customers to say, what are the elements in the code that matter to you? Where do we see bottlenecks? Part of this can be solved in software. Part of this will be solved in hardware in future generations. So this feedback we have always with customers. The deeper you can get with any given customer, the more you can understand what they care about, what codes they care about, and how you can best perform on those codes.
So the Accelerate project actually gives you a very, let's say, nice, private, trustful environment to really work with the code developers. How far do you go from the processor developer perspective? How far do you help them?
So if you look at the makeup of SiPearl and frankly other processor companies I've worked for before, we're usually about 50% hardware and 50% software. So software, and even looking in the software group, we have a systems team. Now we don't build systems, but we have to understand the constraints of systems. We do reference designs, we do demo platforms, and work with then end users to build demo platforms or even systems with us. That's a big part of what we do in SiPearl, and that also drives some of the design constraints we have. So for us, this is a big value. How deep do we go? It depends. It can be at the application level, looking at, it can be at tuning codes or figuring out how do we find bottlenecks within the codes and improve them. It can be at the framework level. It can be down to even the BIOS level in some cases, and finding out how we can improve performance by changing things at that level. So it really it ranges through the software stack, and we look at all levels. We have to. Right. And then an example might be, so then we see a bug or a feature that we can add at the OS level. So then we
don't
would work
add
on
bugs,
this.
please. Just features.
Well, then we would upstream this. I mean, there are always bugs in software, right?
I'm familiar with that.
Yeah, I'm sure you are. But then this would get upstreamed to SUSE or Red Hat or both, or right. At this level as well, then we get involved and then try and make sure that this gets upstreamed appropriately.
Yeah, great. So if we look now a little bit into the future, you of course, there's a roadmap, and there's of course also NDA. It's clear that you can't talk about anything, but not anything, but some things.
Sure.
But what message would you like to convey to our listeners regarding the future? So what could they, let's say, prepare themselves for?
Sure.
Or
so we've talked publicly about we're doing our first 2 generations are focused on HPC. Now there are other applications that these chips can go toward. Specifically, AI is quite interesting, and we have some features on our chips that fit very well for inference. But then beyond that, we're also looking at data center and even then edge processors. And edge can go in a number of different directions. If I look at the different, let's say, industries that are strong in Europe, we're quite strong in telecom. We're quite strong in automotive. Future cars could be seen as a kind of an edge server. Right, and they'll have a comm piece. They'll have certainly server functionality, and then display. There's a number of things in the car that make it unique. There are certain requirements that ADAS, self-driving cars will require. Latency being one. So that's an area that's quite interesting to look at as a sort of an edge HPC processor, an edge data center, an edge server processor. Let's say, looking at the communication market, there's certainly with 5G and 6G networks, either servers that can be at the edge, close to base stations, or even embedded in base stations in some ways. This is an interesting market to potentially look at. Then we talked about data centers. So today we're seeing a shift in data centers based on AI. We may see some what used to be in Europe, let's say just small to medium-sized data centers start to grow into these new markets. As you see shift in market, there's opportunity. So this is specifically around Europe. The other thing that SiPearl is looking at is, so we're starting in Europe, but we're looking worldwide as well. So we're talking to other markets, and we're looking at, again, how can our niche focus fit other applications, and then how can we grow this over time? So it's both in terms of different markets and in terms of growing to a worldwide market from a SiPearl perspective. And then how does that benefit Europe? Again, creating ecosystems, bringing technology into Europe. I mean, this goes to every level. It goes into universities and how we educate. Today, we haven't been educating on processor development for the last 20 years. We have people who are good at this. They're usually working overseas, but we aren't focused on this. Even in focusing on HPC and even in STEM in school. I mean, so the more industry we have, the more available jobs we have, the more that people can look up and say, I could do that. That'll help to drive this. One company's not going to do this, but creating ecosystems of companies that will.
Making it more attractive to go towards that direction.
Exactly. I mean, I can tell you, probably the same for you, when I went to university, one of the things I looked at was, where can I work? Where can I actually work?
Well, actually, I didn't. But
okay.
Yeah.
Yeah. So, I mean, that can also drive decisions on what people study.
Yeah.
Or just what they see around them.
Great. Okay, thank you, Greg. That's been great, and we will follow what happens at SiPearl, and looking forward to using your systems. It's been great to have you, and so thank you, and see you soon.
Thank you very much. It was fun, and it's been great to be a member and a part of Accelerat as well.